All right, now I'm going to do a video where
what C equals.
Sorry. Now I'm going to do a video where we're actually going to get to decide how we're going to approach the problem. I just kind of want to show you how to think about that. And then I'm going to try to go ahead and finish the 2 application problems as well. So this will be the 3rd and final video on section 9.3. All right, so this says to solve the quadratic equation using any method. So sort of the way you approach it is you kind of get it, you think about whether you can use factoring. You try to use factoring if it's appropriate. And then if factoring doesn't work, you typically jump to the quadratic formula, unless you have something that can easily get in the form, like x squared equals some number. Then you use the square root property. So your usual plan is to get the quadratic equal to 0. And then if it factors easily, you use the zero product rule, factoring basically. This is really factoring method. Oh, I don't know why it did that. This is really using the factoring method, okay? So typically, if it looks like x squared equals just a number here, there's no x term by itself, then I use the square root property. Otherwise, I get it to where I have the quadratic equal to 0, and then I give factoring a quick try, and then if it doesn't factor or it's not easily factorable, I move on and use the quadratic formula. Okay, so on number 8, I would first subtract 3. Okay, and then 3 can only be broken down into 1 and 3, so I don't see how to get, and this first 3 is the same, so like factoring is not going to work because I'd have to use a 3x and an x, and then I can just do 1 and 3 this way, which gives me a 9x and a 1x, or 3 and 1 that way, which gives me a 3x and a 3x. There's no way to get a 1 there in the middle. Okay, so that's not factorable. So next, I'll identify my A, my B, and my C. So A is 3, B is 1, C is -3. So I'm ready to use the quadratic formula. So it's opposite of B, square root of the B value squared, minus 4 times the A value times the C value, all divided by 2 times the A value. So opposite of B would be -1. 2 times 3 is 6. Under the radical, 1 squared is 1. Then see how I have a minus, but then another negative? That makes it plus something, and that would be 12 times 3, which would be plus 12 times 3. That's 36. Okay, I always get these too long. Okay, let me shorten those a little bit. So I have -1 plus or minus the square root of 37 all over 6. 37 is just, it's prime, so I'm really not going to be able to do anything to simplify this. So that is my final answer. It's really 2 answers. -1 plus the square root of 37 all over 6, and -1 minus the square root of 37 all over 6. Okay. Now, you might think number 9 is set up ready to take the square root of both sides, but you got this extra little x over here. So that kind of prevents you from using the square root method. So I would subtract the 12x to get it equal to 0. Now, you could use the quadratic, and you could let a equal 8 and b equal -12 and c equal 0, because it's like you've got plus 0 there, and it would work. So if you wanted to, you could do that. But probably the most efficient thing is just to factor. See how 8 and 12 are both divisible by 4. You could also factor out an x. So you would have 2x minus 3 left. It just doesn't factor into 2 binomials. So you know either 4x equals 0 or 2x minus 3 would equal 0. Now, for 4 times x to equal 0, even if you divide by 4, you could divide by 4, and you'll see that x would have to be 0. That is one of your answers that you need to put into the system to get credit. The other one would come from adding 3 and dividing by 2, so we wind up with x equaling 3/2. Okay, so your 2 answers are 0 and 3/2. Here, the two answers were -1 plus square root of 37 over 6 and -1 minus square root of 37 over 6. Okay, so you kind of expect there to be two answers. Normally, they'll let you write it condensed if they have that plus or minus notation. Otherwise, these are your two answers. You can I usually copy the first one and then put a comma and paste it and then just change it from plus to minus to save a little time typing. Oh, I hate it when it moves. Let me see if I can get it back. Okay. All right, now look at number 10. See how that is something squared equals a number? This is a good candidate for the square root method, even though it's got that extra 2 and 5 on it. I just think of it like something squared. That's what it is. Let me write that better. Let me show you what I'm talking about. So it's got something squared equals 7. So how about we just square root both sides? Don't forget to take both the positive and negative square root of 7 over here. So this is 2y minus 5 squared. We're going to square root that side and square root the other. That square root undoes the squaring. So you wind up with 2y minus 5 on the left equals positive or negative. Don't forget that. That's the biggest mistake on number 10. Don't forget, I've been teaching forever. I see this all the time, and I try to warn you about it, warn students, so you don't miss points there. You should get two answers typically on these. So don't forget that there's both a positive and a negative square root of 7. Okay? Square root of 7, though, doesn't simplify. All right, now at this point, I'm going to go ahead and add 5. Now, but watch this. This is kind of tricky for students usually. When I add 5, I don't want to write it at the end because you'll get confused when I write it as to whether I mean the 5 is under the radical or not. I'm kind of thinking about how these answers typically turn out. So when I add the 5, I'm going to write it right there in front of that plus or minus. Okay. Then after I do that, I'm going to come in and divide by 2 on both sides. And so my answer turns out to be y equals 5 plus or minus square root of 7 all over 2. 7 is not it's not possible to do the square root of 7 or to even simplify it. So that would be your final answer. Now, if you tried to do that one without using the square root property, then you have to take 2y minus 5 and square it. So don't forget to write it twice. You could do this, but it's not the most efficient method. Then you'd have to FOIL. So you'd have to get your 4y squared minus 10y minus another 10y plus 25. Collect your like terms. Subtract the 7. Get it to here, and then go from there using the quadratic formula. So it's kind of a lot of extra work, really. It's a possibility, but the best method is to recognize that this is a good candidate for the square root method. All right, now with number 11, the way to think about this is that somebody factored before this over here was equal to 0. You're not supposed to factor until you got it equal to 0. So we have to fix the problem. So we're going to unfoil. We're going to get it back. It would be x squared plus 3x minus 5x minus 15. We're going to combine our like terms and add the 7. So we get x squared minus 2x minus 8 equals 0. Then at this point, I'm thinking about that 8, and I'm realizing 1 and 8, 2 and 4, there's a way I might be able to make that just factor. So that's what I'm going to try, an x and an x, a 4 and a 2 with the 4 negative. Double check it. Yep, that'll factor. So this one would wind up being x equals 4 or x equals -2. Okay. Now let me show you from here what would happen if you used the quadratic formula at that point, because it says use any method. Okay. If it said use the most efficient method, you ought to have factored that. But let me clear out a little bit of room because I want you to see how it looks at the end if you had used the quadratic. So let's suppose you were here and you decided that you're not a big fan of factoring. So you thought, well, I'm just going to use the quadratic formula. You can do it. You have to be careful, but you can do it. Okay, so opposite of b, square the b, minus 4 times the a times the c, all over 2a. And that's telling you what your x would wind up being. So that's going to be, oops, meant to put a 1 where that a was right there. Hold on, it's not in my erase mode yet. Let me see. Try that again. There we go. 2 times a, which is 1. So this would turn out to be positive. Opposite of negative 2 would be positive 2. 2 times 1 would be 2. Negative 2, when you square it, is positive 4. We have a minus and another minus, which gives us plus, and then 4 times 8 is 32. So we wind up with 2 plus or minus the square root of 36 over 2. Now what tells me, say I hadn't already done it the other way, what tells me this would have been factorable is, do you see that 36 is a perfect square? So this becomes 2 plus or minus 6 all over 2. And so that means one answer is 2 plus 6 over 2. The other answer is 2 minus 6 over 2. Get a little more space. 2 minus 6 over 2. And 2 plus 6 would be 8. When you divide that by 2, you get the 4 that we got before. And if you did 2 minus 6, that would be negative 4 over 2, which gives us the negative 2 that we got before. So you get the same answers. It's just a different approach. And I just wanted you to see that this is going to happen. If it was a factorable equation, when you do the square root, you'll have a perfect square underneath there. And then some people don't realize that when they get something that looks like this, you have got to separate it because 2 and 6 are like terms. These are like terms. So that means if you separated it into the plus and the minus case, you'll be able to go further. So you can't stop at this point right here. That would not be fully simplified. Okay? All right, let's go ahead and look at these application problems. Let me go ahead and just get this onto a new page. All right, so one of them this is a really common one, so I just thought I would get you to look at it. So this says the volume of a rectangular package is 325 cubic inches. It's volume, so that's why it's cubic inches for the unit. The length is 2 more than the width. The height is 6 inches, and then you're supposed to figure out the dimensions of the box to the nearest tenth of an inch. So the 6 for the height of the box is pretty obvious, but here the length is 2 more than the width. So what they did is they let x represent the width of the box, then the length, so that's the width right there. Then the length is 2 more than that. So that's where that came from. That would be 2 more than the width would give you the length. So you need to know this, that the volume of a rectangular prism, hold on a second, let me get it. Let it finish whatever it's trying to do. The volume is length times width times height. Area is length times width. Volume is length times width times height. So you'll just plug everything in. I'm not going to put it in that same order. I'm just going to do x times x3. I don't know why I said 3. I meant 6 times x times the x plus 2. Okay? All right, that's the volume. But don't we know that that volume is supposed to turn out to be 325 cubic inches when we're finished? Okay, so what I'm going to do is distribute the 6x. That would give me 6x squared plus 12x. Okay, then I'm going to subtract the 325 to get it equal to 0. And then, this might be factorable, but there's no way in the world I'm going to try to factor that because 6 has a lot of possibilities and 325 is just too big for me to think through. So I'm just going to use the quadratic formula. So I need the opposite of b plus or minus the square root of b squared minus 4 times the a value times the c value. Remember to get the negative on that c value. All of that over 2 times the a value. So that's negative 12 plus or minus on top. It's 12 on the bottom, but don't cancel 12 into negative 12. Don't divide that. Okay. You got to wait to see what you got over here. So here we have 12 squared, which is 144. This is minus, but this is minus as well. So that's going to ultimately be plus something. Okay. So now I need to just multiply the 4, the 6, and the 325. 4 times 6 times 325. And I wind up with 7,800 for that part. And then when I add 144, I get 7944. And then I have no idea whether that's a perfect square or not. And besides that, when you look at this up here, it said approximate the dimensions to the nearest tenth of an inch. What that's trying to tell you is do not take this and start breaking it down, right? You don't need to do that. You're allowed to approximate it to the nearest tenth of an inch. So just do the square root of 7944 on the calculator. Okay. And then since it wants the nearest tenth of an inch, I normally keep a little more accuracy early on. So I might keep like 2 decimal places. So square root of 7,944 is 89.13 about. Let me change this because I'm rounding. So that's approximately that over 12. And then again, don't divide 12 into 12 or anything. You need to, at this point, separate it into negative 12 plus 89.13 all over 12, or negative 12 minus 89.13 all over 12. The only thing that changes sign is in front of the 89. Both of these are minus 12s. So a negative 12 plus 89.13 would equal 77.13 positive. And when you divide that by positive 12, you get 6 about. I'm rounding again. So let me go ahead and at this point I'm rounding again and I get 6.4. And I'm rounding to the nearest tenth now because I know I'm going to do that for my final answer. Now the other one is not going to make sense, is it? Because when you do negative 12 plus a negative 89.13, you get a negative 101. When you divide by 12, okay, you get, oops, that's exact. There. This is approximately, you get a negative number. You get negative 8.4. And we're talking about a length of something, so it can't be negative. Okay? So then you go back and you say to yourself, all right, so this box is 6.4 inches by, and then here you have to do 6.4 plus 2, that's plus 2, by 8.4 inches by 6 inches. Okay? And then I always just check it. Take 6.4 times 6 times 8.4, and you should have something. Won't be exact because we did round, but you should have something close to 325. Man, it feels so much further away from that. I got 322.56. So let me just double check my work in there. I mean, you will get things that are kind of pretty far away from what you're expecting. So let me just double check, though, that I didn't have a typo. So I subtracted minus 4 times A times C. So that is plus. Let me do 4 times 6 times 325 again. Now there, I typed it wrong. 4 times 6 times 325 is 7,800. When I add 144, I get 7944. When I do the square root of that, I get 89.129. And I kept to the nearest hundredth. Maybe I shouldn't have even rounded that much. It was really 12911,982. So I'm going to keep all of that in there to see what happens. So if I take that and subtract 12, I would get that. When I divide by 12, I would get 6.43 if I round to the nearest hundredth. Okay. And if I did 6.43 by 8.43 by 6, let's see what that turns out to be. I'm just trying to show you that it's really just a little bit of rounding. Yeah, now that turns out to be 325.2 when I check it. So I was, when I plugged it back in, it was off by like 3 whole, it was like 322 cubic inches. So it's worth checking, but just a little bit of rounding can make that happen. So this should be what they're expecting. Okay. All right. And I did one more, didn't I? Do more than one? Is that the only application? I thought I had 2. Oh, maybe it was the previous one. No, there is another one. Where is it? There's one more on my guided notes. Maybe I decided to take that off. I don't know. I'm going to go ahead. Maybe I accidentally deleted it, but I've got it on my guided notes. So let me go ahead and do it here. It just didn't, my printed guided notes, it just didn't download here. So number 12 is a problem. I'm going to read most of it and just write down what we need. It says a baseball is hit from a point 3 feet above the ground with a velocity of 100 feet per second at an angle of 45 degrees. And then it gives you the path of the baseball. This is a really common problem, so that's why I kind of wanted to do it. But they already did the hard part. So that already takes into account the 3 feet above the ground, the velocity, and the angle at which it was hit. X is the horizontal distance from home plate. Horizontal distance from home plate. And Y is the height of the ball in feet. Okay, and it says how far from home plate does the ball hit the ground? So the concept we're thinking about is that the ball is going to go up and come back down. And the question we have to answer is that. How far from home plate does the ball hit the ground? All right. So the idea is that if you're on the ground, if you've hit the ground, that Y equals 0. That's what hitting the ground tells you, is that the height, this is the height, that the height must be 0. That's the horizontal distance from home plate there. Okay. So basically, we're going to take this equation and we're going to put a 0 in for Y. So we're going to have negative 0.0032 x squared plus x plus 3 equals 0. And our job is going to be to solve that. Let's see if I can get it to space. Just trying to get a little more room here. Nope. Didn't get paper before I did it. So let me transfer that equation right there to a new page. Let's see if I can copy it. Let's see if it'll let me. Oops, thought I was in my lasso mode. Okay, let's see if I can copy that and just get to a new page and we'll finish it on up. Okay. So there's the equation that we're trying to solve. So A is negative 0.0032. B is positive 1. C is positive 3. Now you could go through and multiply through by a negative 1. fact, I think that would be a great idea. So you can always do that. So let's do that because I like my A value to be positive. Now I could do this, or you could multiply through by -1, which would make it positive 0.0032x squared minus x minus 3 equals still 0. So the A would be positive. I just like the A positive because the A is on the bottom. And so you get kind of a strange form sometimes on that. But it's really up to you whether you want to do that or not. But that's what I tend to do. So I'm going to put in -1 for B. I'm going to square that. I'm going to do -4 times the A times the C. All of that divided by 2 times the A. You know, thinking about it a little more though, since we're going to be doing a decimal approximation, when you're doing application problems, you typically just approximate your answer. You don't actually have to simplify the square root. So really it would be just as easy if you had done that, if you had used A equals -0.0032, B equals 1, C equals 3. So I kind of take that back. I think you could have done that really just as easily. Okay, so one of these two. Okay, you would have had opposite of B. Under here, you would square your B -4 times that A value. That's the worst part, all those zeros. Times the C all over 2 times your A value. Okay, so either one of those would have worked. Okay. All right, so let me think. Probably most of you would do this one where you don't get rid of the negative in front. You would use the one where you just left it the way it was, which was this, and then just identified it. So let me continue using that one. So we'd get, I'll use that way. So we'd get -1 plus or minus square root of +1. This is minus, and so is this. So that's going to be plus, and then you have 4 times, I'm doing it on my calculator, 4 times 0.0032 times 3. I already know it's positive. So that's plus 0.0384, all of that over, and then 2 times that would be -0.0064. Okay, so that means under the radical we have 1.0384, all of that over -0.0064. Okay, so the square root of 1.0384 turns out to be 1.01902. And I'm going to just round because I know at the end it's okay to round on these. But then here you got to be careful because you got to do -1 plus 1.01902 over -0.0064. And you have to do -1 minus 1.01902 over -0.0064. And I just kept a little bit more accuracy when I approximated that square root right here and here, just to minimize the round off error I might get. Okay, so I'm going to do -1 plus 1.01902, and I get a positive number divided by a negative number, which is not going to make sense because you're not going to have it a negative distance from home plate. But this one's going to be -2.01902 divided by -0.0064, which will be a positive number, and then we'll figure out what that is. So that's 2.01902, and we're dividing that by 0.0064, and we get a positive 315.5, and I rounded that again. So I get around 315.5. and just watch it depending upon what they ask. They might say round to the nearest whole, or they might say round to the nearest tenth. So you might just say the ball would be about 315, 316, hit the ground about 316 feet from home plate. Okay, ball would hit the ground about 316 feet from home plate would be your interpretation. Okay, so let me stop that and post this last video that looked at how to make a decision about how to solve a quadratic equation, which method you're going to use. And then there were a couple of the classic applications at the end.